Hi everybody. This will be my last video and my last visualization for regression. And I really like this one for two reasons. One, I think it really shows how useful it can be to use notebooks for teaching, computational notebooks. I just think it's a great resource for the students to be able to interact, with your notes. And also, this gives the students a little bit of the data science workflow. So we're doing some data wrangling here, and then some modeling, and then prediction and testing. So let me just quickly go through and let you know what's here. So what I'm doing is I'm trying to predict the number of wins that a team in Major League Baseball will have based on the total point spread for the season. So if you take how many runs the team scores for the whole season and subtract how many runs were scored against them, can you use that to predict how many wins they will end up with? So the first data set here is just the raw data, and this is from the layman data set, and it's just wonderful. There's just so much here. So there's an entry for every baseball team in history, and each year they were in existence. And then you have a number of statistics for each team. Like, for instance, this would be how many runs they scored, how many at-bats they had, how many hits they had, and so forth. And so just by clicking on that arrow there, you can have access to see, what's available to you. So that's the raw data. And then in this one, I just use a little JavaScript to pull out what I want. And so you can see that there's almost 3,000 records in this one, but I've limited it to just 570. And what I did was I decided to just look at years 2000 and beyond. I think this goes up to 2018. So I'm only taking those records, and I don't need every statistic. I need how many wins the team had, how many runs they scored, and how many runs were scored against them. So that's all I need for this project. So then I keep doing some data wrangling there. I take this data set and just change it around a little bit so that instead of having two columns here, I have their difference. All right. And so now I've got this is basically my X here, right? What I'm using to predict my Y, which is number of wins. And then finally, I take this set and I split that into a training set and a test set. So I tried to take about 70% of these records for the training set. And so I did that by just limiting it to, I think I go up to like year 2013 or something like that. And then I use the records after that as my test set. Okay, so this goes from 2000 to 2012, all the records from those years, and this is 2013 and beyond. So what I'll do is I'll figure out the estimate with this set, and then I'll test to see how well it does on this future data set. Okay? All right. So here in the first part, I'm trying to find my estimate, this blue line, right? So I have some radio buttons down here, and I have it clicked here as visual best, which means that all we're doing is we're sort of eyeballing this, and we're trying to find the best fit just with our eyes. And we're helped up here because we can see what as we change these sliders, we can see what the root mean squared error is, and we want to try to make that as small as possible. So you can see, how well you can do there. And it also gives you the equation of the line as you change it. But remember, there is a mathematical way to get the absolute best. So we would want to see that too. So if we click here, it gives you the equation of the absolute best fitting line. You're seeing it there, and you're seeing the root mean squared error, which is 4. So this is kind of interesting because the Major League teams play 162 games, so this is about 81 games. So it says that you can predict the number of wins, right, just by taking about 81, which is half the season, and then tacking on 10% of the point spread. And you're going to predict then the number of wins, I mean, this roughly, right, within 4. So that seems pretty good. So this is what we end up with as our estimate, this equation here. So then what do you do with that? Well, now if you have some data from a future year, you can use the point spread to try to predict how many wins a team will have that has that point spread. So if we go down here, let's say we put in 90 win, or I'm sorry, a point spread of 90, which means that the team scored 90 more runs than their opponents did that year. So 90 gets plugged into the equation, right, for X, and the prediction is about 90 wins. How about a point spread of 200? We're predicting a little over 100 wins there. How about a point spread of negative 200? All right, we're predicting about 60 wins in that case. Okay? And so how well does it do? What if we take a whole bunch of data and make these predictions and then compare them to what really happened, right? Because we have this data from 2013 to 2018. We know what happened. So that's what I'm doing here. I'm taking, this is the test set here. You can see that there's not as many, right? About 30%. The line here is the line, the best mathematically fitting line that we came up with here. All right, so that's the equation that we're using. And here's how well the test set fits to that line, 4.21, which is really not too bad. So I think that right there, that tells you that this is pretty good for prediction. All right, it's going to work for future data sets. So now you can feel somewhat confident, right? If you go to the year 2019 and you say, well, we'd like to have, we'll probably need to have 95 wins, right, to make the playoffs. What does that mean about the point spread? How many runs are we going to have to score versus the runs scored against us? What does that have to be for us to make 90 wins? And so that's it. So I think that I'm going to go on then to logistic regression after this, because I do want to talk about classification as well. So I hope it's useful.